Okie dokie. Thanks for joining me for yet another fun-filled statistics, easy for me to say, statistics lesson. We're going to talk about other types of graphs. So we've already been covering the frequency distribution, histogram, ogivs, frequency polygons. And now we're going to head on into Pareto charts, time series graph, pie graphs. Oh yeah, I love the pie. And stem and leaf plots. So I can't cover pie graphs today, I'm too hungry. So let's go to Pareto charts and time series graphs, and hopefully this will be a quick and easy video. So starting off, in addition to the histogram, well, we've already kind of given that away. We're going to be doing a Pareto chart. Does that look familiar? Oh yeah, bars. B is the time series graph. And that should look familiar as well. Time is on the x-axis, and you got the points, and you got the line. And then pie graph. Oh yay! Get to break out the protractors in this section. So most of us are familiar with these three, and so I think this section is going to be quick and easy. So let's get rolling. The Pareto chart. A couple things I want you to notice is we've already done the histogram. Fancy name for a bar chart. Pareto chart. That sounds much fancier than bar chart, but that's all it is. So if we look on the side here, frequency is just like you have been doing with those other graphs that you had. You've got a frequency there. And then at the bottom, though, instead of having numbers, notice you've got auto, bus, trolley, train, and walk. This is how people get to work. And so that kind of gives you a clue as to what a Pareto chart is. It's a histogram that represents a frequency distribution for a categorical variable, and the frequencies are displayed by the heights of the vertical bars, which are arranged in order from highest to lowest. So if we look back here, if you notice all these bars go down in descending. They go from high to low. So that's what the Pareto chart is. That's really the only difference in just a normal bar chart. When should you use the Pareto chart? Well, when you're trying to impress the ladies. No, it's when the variable displayed on the horizontal axis is qualitative or categorical. Yeah, that's not a very good pickup line. Hey baby, you want to see my Pareto chart? It never does work. Okay. We're going to do an example here just to give you an idea. Here's the states. Here's the cost per mile, average cost per mile on turnpikes. They're talking about tolls and different things like that. Now, if you haven't seen this symbol before, which I hadn't seen for a while, that's the cents symbol. So this is 2.9 cents. Very first step, it says arrange the data from the largest to the smallest according to frequency. So which one's the fat cat? Florida. So he goes on top. Florida. Oh yeah, love that state. Then comes Pennsylvania. Gotta love the Amish. Then comes Oklahoma. The wind. You can finish it. And Maine. Oh yeah, got some lobster up there. And Indiana. Hey, Indianapolis 500, fast cars. Pretty nice place. So here's the order from top to bottom. So that was our first step. We got those arranged. It says step 2, draw and label the x and y axis. Notice it says label. Nobody wants to ever label them. Please label them. So if we're drawing those x-axis and the y-axis, notice I have 1, 2, 3, 4, 5 spaces. Because I'm going to do 5 bars. There's 5 states there. And then going upwards, I've got 1, 2, 3, 4, 5, 6, because I'm going to go, each of those little tick marks is going to be 1 cent. Pretend like I got them equally spaced. I worked on it. It's not perfect, but you know. So on the bottom, it's going to be the state, and on the top is going to be the cost per mile. You might want to put cost per mile. And then there's our states: Florida, Pennsylvania, Oklahoma, Maine, Indiana. So let's look at the cents here. So like I said, I was going up by ones, 1, 2, 3, 4, 5, 6, up the y-axis. Draw the bars according to the frequencies. So if you remember, Florida topped out at 6 cents. So there's that bar. Pennsylvania was next with 5.8 cents. Then Oklahoma, 4.3 cents. Maine was 3.8 cents. And Indiana was a measly 2.9 cents. So then it says analyze the chart. Well, if we look at these bars, you can see, you know, Florida has the highest cost per mile. It's almost twice as much as Indiana. That's the kind of conclusions they want you to draw by looking at these charts. Alrighty, make the bars the same width. These are the suggestions for making a Pareto chart. Oh, the Pareto chart, she's so beautiful. So number 1, make the bars the same width. I tried. You can do better. Arrange the data by descending frequency, which we did, so that your bars should go down toward the ground. Make frequency unit equal in size. It means we can't skip from 1 cent to 5 cents to 8 cents, Keep these distances the same. Keep these units the same. And that's it for the Pareto chart. Let's talk about time. Time series graph. Now this is interesting, isn't it? This is the temperature over here, the time over here, and it shows the trend. And this is like the time during the day. You can see the peak heat happens there at around 5-ish there. So it's temperature over a 9-hour period. Couple things on the time series graph. Time always goes on your x-axis, and you use this type of graph when data are collected over a period of time. I can't get used to that. I always want to say data is, but it's proper is data are. And remember that the period of time is always on the x-axis. So keep that in mind as you're doing these. All right, let's jump right into an example, shall we? So here's the number in millions of vehicles, both passenger and commercial, that use the Pennsylvania Turnpike for the years 1999 through 2003. Gosh, can you believe that was a decade ago? Construct and analyze a time series graph for the data. All right, step 1, what are we going to do? Draw and label the x and y axis. So on the x-axis goes the, anyone, year, and then the y-axis is going to be the number. So here's your x's, here's your y's. So let's draw la la la, boom 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 boom, boom 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 boom. There's the year, there's the number of vehicles in millions. So I like to get those labels on there. And let's go ahead and put the units on there. So the year 1999, you got 2000, you got 2001, you got your 2002, and you got your 2003. Then going up in millions, notice this is like 156 million. Let's see where we started. So the low was 156 million. So 150, 160, 170, 180. Just happened to be that these were in increasing order. That's just the data. We didn't put them in that way. That's the way it fell. So then step 3, ooh yay, points. So 1999, 156.2, you're going to have to guesstimate. And notice these units are equal units apart. It's a nice even round scale. So there's about 156.2. 2000 is going to be up there at about 160.1. Then you got your 2001 at 162.3. Then you got your 2002 and 2003. Step 4, connect the dots. La la la. So we're connecting those dots, and then we analyze the graph. We're looking to see if things are increasing over time or decreasing over time. Is there a spike in the data? That's all things that we can get from this time series graph. So we're looking, what's the trend of the data over time? Is it increasing or decreasing? For example, if they did a time series graph on people driving horse and buggies from 1800 to now, you would expect that to go down quite a bit. It would go down this way. Positive slope is increasing, negative slope is decreasing. Pretty logical. So when you analyze a time series graph, that's what they're saying here in your notes. Look for a trend or pattern that occurs over the time period. For example, is the line ascending or decreasing? Another thing to look for is the slope or steepness of a line. A line that is steep over a specific period of time indicates a rapid increase or decrease over that period. How can you compare two sets of data on the same graph over a given time period? Well, that is kind of a neat thing. You can do two data sets, do one different line, a different line for each data set. So two data sets can be compounded by using a different line for each data set. And you'll see, they usually do it by year when they're doing for the months of the year at the bottom, and here's 2010's data, here's 2011 data, and you can see where the lines are. Okay, that's it. Hopefully that was painless, and I will see you at school. Bye.